really want to thank the people that have shown up today. I'm just going to get right into it today. I'm just going to get right into it. Oh, that's right. People in here can't see anything yet. Let's help them out too. All right, I want to thank my 3 people. I want to thank my 3 people for showing up today. Hey, if you're missing out on the extra credit. They're going to get the extra credit today and not you. All right, so a few announcements. I know you can read. Yes, I put this together. So this is the final chapter of our Computing Essentials 2023 text. So you can now complete the 4th exam covering chapters 11 through 13. You'll need to complete all 4 exams in this class for preparation for the final exam and to also have your score be accurate in Canvas. Because remember, I said it always drops your low score. So when you finish the 4 tests, then your score becomes accurate. Here's the rest of the schedule. So Thursday, Access Guided Project 4-3. Next week, so I'm done lecturing, where it's lab only the rest of the way out. Next week, Tuesday, is our only class. That's PowerPoint Guided Project 1-2. The following week, PowerPoint Guided Project 2-3 and 3-1. Finals week, our only class for finals week is on December 10th. So we're not going to be here December 12th. We're only going to be here December 10th on finals week. And yes, it is an in-person final exam. If you do surpass the 1,260 points, which I have people that are eligible for that coming up real soon, then you do not need to be here for the final. So if I do not see you, I'm probably just going to put the 0 in and we'll call it a day. But I will confirm with everybody in the coming couple of weeks that are eligible for the 1260. If I check the grade book and I see you are there, I'm just going to send you a message and say congratulations. Again, it is totally up to you if you want to show up to the final or not. But again, here's my first hint to you. You really want to show up for the final even if you haven't prepared for it. And you want the 150 points, you should show up for the final. That's clue number 1. I will give another clue sometime soon about how the final is going to work, but you do have a clue up there. It does say you need to complete the 4 exams for preparation for the final exam. Because on the final exam, you should see some questions you've seen before. Wink, wink, nudge, nudge. And one last time, there are the points. It's on the feed. It's on the video. 980. If you get less than 980 points, you will have to retake the class. And why do I say that? Because of this. You knew it was coming. So, my people in the green and blue section, that's the 4 up in the upper right quadrant. I'm concerned about you. 200 to 680 points. You should have more than that. My 5 people in the 680 to 920, I'm not worried about. They're going to pass the class, most likely. My people that are the 6 and the 2 on the left, I know you're getting the A in the class. You've got to get the A in the class. So the 5, though, you got to do some work to get your A. But the people in the 6 and the 2, yeah, you're probably going to get the A in the class. All right. And hey, you don't know who's here in attendance today, but guess what? They're probably all going to get the A in the class. That's you. I'm talking to you. All right. I know it probably looks weird on camera, doesn't it? Oh, if you notice everybody in the class, your desktops probably have new pictures today. Mine does. Mine does too. I don't know. Like, it has like the little, like, yeah, the desktop pictures changed today. No, I did not do that to your computers because you don't have Hello Kitty, so you're safe. You all survived the Hello Kitty, so I think we're good. All right, our final chapter, which is not going to take very long, even though I do have a cheesy 3-minute video that I'm about to play, covers programming and languages. So one thing I need to point out for today's chapter is this looks eerily similar to chapter 12. You're going to see another cycle. It's going to look just like the last cycle you saw, but today we're going to talk about the software development life cycle and not the systems analysis life cycle. All right, you know I have to have a video. This is a lot more current than the one I usually play. So people at home, get your popcorn ready. Get your popcorn ready. And here we go.
I think the greatest value of learning I think everybody in this country should learn how to program a computer. Should learn a computer language because it teaches you how to think. It's like going to law school. I don't think anybody should be a lawyer, but I think going to law school would actually be useful because it teaches you how to think in a certain way. In the same way that computer programming teaches you in a slightly different way how to think. And so I view computer science as a liberal art. It should be something that everybody takes a year in their life. One of the courses they take is, learning how to program.
Programming is where you're describing to the machine how to do something. And so telling it how to play tic-tac-toe, telling it how to play the board game Monopoly, telling it how to convert numbers from one base to another. And the idea of, okay, there's these simple instructions, but if you put them together, then you can synthesize something quite complex. It's a fascinating kind of mathematical thing. How can you make it fast? How can you make it small? The fact of understanding how the computer works gives you a real sense of what it can do and what it can't do. There's a lot of great jobs out there, and so we don't have programming enough on the curriculum. But I certainly wouldn't put it at like math or literacy. But there is a lot of innovative stuff that make it more interesting. It's not just for nerds like it was when I did it.
Programming is one of the only things in the world that you can do where you can sit down and just make something completely new from scratch, whatever you want.
I took one computer class in college and I cheated at it, but when I started really getting into it, I could spend 20 hours teaching myself the program and writing programs, and I was like, I had no idea. I love this stuff, right? And I would just sit there and days would go by, and I loved it, right? And then as I got more into those businesses, it was like, this is great. I'm having a blast doing this. But I didn't know that's what I would love to do until I tried a lot of different things.
For a few, it might lead to a lucrative career as so-called coders. But for everybody, it'll teach them how to think, how to imagine, how to create. It'll provide a better understanding of the world and an indispensable foundation for life.
A lot of people think about programming as the language that tells the computer what to do. But in fact, if you look at the office behind us, programming, when it's really good, and the language itself, the programming language, is actually communication between team members, right? It's the difference between being able to maintain something and enable it to live and to sustain versus not. So if it's a great language and everyone knows it, then it brings the team together and they can really do amazing things very quickly.
On and my picture. Okay, there we go. Okay, so again, it's not really always about just all these numbers and all these letters and all these phrases and all this code. It's not really about that anymore. It's more about understanding, why are we even doing it? Why would you even do it? Who are we trying to help? What are we trying to accomplish? And that's the first phase, believe it or not. That's the first phase today in the cycle that you are about to see. So in chapter 4, from last chapter, phase 4 from chapter 12, that was the systems development phase. So in that phase, we talked about software, or acquiring the software. Now, an option that companies have is to actually create the software themselves or develop that software themselves. So please keep in mind that what I talk about today is inside of that 4th phase in the systems life cycle that I talked about last week. All right, so when it comes to programs and programming, here it is. Software development life cycle, 6 steps instead of 6 phases. If you hear me say phase instead of step, my brain is still in chapter 12. So if you hear me say that, just remember it's steps. So when we talk about a program, we're talking about something that solves a problem-solving procedure. We are the ones that have to tell this inanimate object that sits in front of us what to do. I've been saying this all semester. Long. We have to tell this thing that's in front of us what to do. It doesn't know what to do unless we tell it that. So with programming, it's a list of instructions for the computer to follow to process data. And keep in mind that software can either come pre-written or pre-packaged, kind of like Microsoft Office, right? You install it, you get what you get, right? Or it can be custom made, which, yes, there is software that companies can purchase that maybe we don't need to use all the software, all the components of the software. We only need to use certain components. So I go back to my time with the colleges, in that our financial system, we bought a custom-made version of it because we weren't going to use all of it. And so Oracle, what they did was they charged the organization less money because we weren't going to use all the components. So they gave us a custom-made version that we could use for what we needed it to do. So as I said earlier, the first step is why? Why are we even going to create this application? Why are we programming? Why are we doing this? You'll notice that there are 5 steps here. And I'm going to go into detail right now about those 5 steps, and they include the objectives, the outputs, the inputs, the processing requirements, and of course, documentation. I know I talked about documentation a lot in chapter 12. It's underneath, not on the side. Okay, now you know how my kids feel. Okay, so in this first step, we really need to define what we want this program to do. I want you to think about how long video games take for this process to occur. I was talking with somebody yesterday how some game that's been online has been in development for 7 years. So I'm like, 7 years? That's like almost a decade of somebody's life doing this. So this stuff just doesn't happen overnight. So program objectives definitely need to, if you're thinking about programming something, I always tell everybody this, start small, start with something really, really basic. Don't try to make your millions of dollars right off the bat, because it doesn't work that way. As much as I would love to say it does, because I get students going, well, I'm in here to get rich fast. The door's over there. So you will get wealthy, it's just gonna take time to do it. So anyway, program objectives, it's the why. Why are we doing it? What do we want? We gotta look at the output. What is the output gonna be? Based on, of course, that output is based on what? It's what we input. So that output's gotta be based on the input. And I like that you see this says end user sketch. That's not a sketch, that's computerized. But anyhow, normally all of this is put together in this step, and it does take some time. The big question here is, what operating system are we gonna run this on? You know the term operating system by now. Here's some review. What kind of operating system are we gonna run it on? What kind of devices are we gonna run it on? How much memory is it gonna take up? How much storage space is it gonna take up? I know, big questions here, right? How many cores of the CPU are we gonna require? What kind of CPU are we gonna require to run this? As people programming, we have to think about these things, because if we don't, if you build some massive application that only a few people can run, you're not gonna be selling too many of those. But if you build, because I know you've noticed this with your phones especially, that there's light versions of apps out there, and there's regular versions of apps, and there's pro versions of apps. So keep in mind that, yes, even in development, these people that have developed this software understand processing requirements. So again, and I know that, yes, I'm pointing to the class next to us. I know that my fellow professor for his class, he's been working on telling the students to download a light version of the application, whereas me, the online person, says, forget that, you install the whole thing. But I do like where he's going with that, so I may be following suit Once he does the research on that, I will happily follow suit. But just keep in mind, there are different versions of these programs. All right, and then you should have a document. All right, we're done with step 1. Like that takes like 5 minutes, right, to do? No, that takes time to do. So once you're done with step 1, have we done any coding yet? Not yet? No, not yet? All right, it's coming. You know it's coming. So step 2, here's our top-down design. I talked about that sort of in chapter 12. We'll talk about it in a minute. But anyway, in this step, we're going to plan our solution using various structured programming techniques. We could use something called top-down design, pseudocode, flowcharts, and logic structures. And I'm going to talk about all 4 of these right now. So this should look somewhat familiar to you. Top-down. So I talked about top-down in chapter 12. This breaks down a specific process in the program. So this is a time and billing process. It's broken down into inputs and outputs. Those are further broken down as you can see going from top to bottom in this image. Can you read the sentences on the right? Yeah? So we call this pseudocode. So yes, in the CIS105 class, that's the Programming Fundamentals class, they actually have an assignment on this where students have to write out the steps, yes, in sentences, before they start thinking about how to code it. And we call that pseudocode. Yes, flowcharts. I told you there was going to be a difference between the ones that you saw in chapter 12 and these ones. Oh yeah, for everybody in here, no, I'm not walking all the way to the right side of that one. I'm just going to go here. So the line that's down here for yes, way down here, coming out of the diamond, it actually goes back up and over here. So I had to cut that off because it was so far, the image was so far off that I just decided to cut it like that. So anyway, you have a start and a stop symbol. They look like pills almost. But those are our terminal symbols that start and end the process, end the flowchart. You see the processes are all rectangular. Any inputs or outputs within the flowchart are parallelograms. Yes, you heard that word, right? It's probably one of the longest words other than conceptualization, right? That was a couple weeks ago. And then we also have decision diamonds, which I've seen some flowcharts. I mean, most people would think, I don't know if you do, I'm going to say most people have told me that normally we only think of that as a yes or a no answer. I will tell you, I've seen flowcharts with like 6 arrows coming out of a diamond, like with 6 different things that it could be. So I know you're just seeing the yes or the no here, but keep in mind, like in the real world, there could be many options coming out of that diamond. So normally questions are asked in the decision diamonds, as you see here. And then, of course, we have connectors that connect one process to another. So they don't really do anything else other than just connect one process to another. So inside these flowcharts, though, you're going to see different logic structures. Now, there are 3 of them. There's sequence, selection, and repetition. Sequence is where one program statement is run, then the next one, then the next one, then the next one in a nice, neat format. Selection is what we call an if-then-else statement. If a condition happens, then a statement is run, and then it continues on through the flowchart. If the condition is not met, another statement is run, and it continues on through the flowchart. So we call that selection. It's a choice between one or another. That's what I want you to think about that as. And repetition, well, as the word states, it's going to repeat, that statement's going to repeat in a loop until the condition is no longer met. So it'll run and run and run and run and run and run and run until it doesn't. So that's repetition. And you'll see all of those inside of flowcharts. Hey, guess what we finally get to do? We finally get to code the thing. Now, here's the other thing I haven't talked about yet. We haven't decided what programming language we're going to use. Now, of course, if we're going to run this on like Apple devices, and we're going to try and create an iOS app, keep in mind that there are only certain programming languages that you can use to develop those applications, like Xcode and Swift, for example. Those are used primarily for iOS devices. Whereas a lot of these other programming languages you've likely heard of, which we'll talk about in a few moments, those can be run on Android devices, Windows machines, etc. Now you use applications. I hope you all use applications. You have. Do you like them to work? When you push a key, you expect something to happen, I hope. You like it to be reliable. You want it to work. You don't want to see error messages. That's why I warn people about error messages, because we don't like seeing error messages. We also want our applications to catch common input errors. So I'm like, uh-oh, I didn't mean to do that. Flipping Pokemon app this morning. I didn't mean to push the one button. I pushed the wrong button and it wouldn't let me undo. And I'm like, oh, come on. So no undoing. So I like to have my apps catch my common input errors. I like it when they ask you, are you sure? And then you're like, ooh, no, I didn't mean to do that. You can say, no, I'm not sure, and it kicks me back. So I do like that too. You do want your apps to be able to do that. Well documented and understandable. I'm going to talk about documentation a lot, because think about this. Some of these applications literally do take years to make. And what if we have a programmer that leaves the organization and they've been working on this code for the last couple of years? Well, it should be documented so that the next person that takes over can see where everything was left off at and they can continue on with the application. All right. So in this step, we are deciding on the language. There are several languages out there. Just keep in mind, JavaScript is not a programming language. I do not know why it's on here. It's a scripting language. Anytime you see the word script, that's a scripting language. Just like SQL is a query language. Just like HTML is a markup language. Those are not programming languages. Programming languages are like Java, C#. There's so many of them. All right, there's so many of them. I used to list them all on the board, but I am not doing that. There are a lot of different programming languages out there. All right, so, come on, there we go. Is there one more? All right, there we go. All right, so once we've decided on the code and we've coded it, now we move on to test the application. This should sound familiar from last week. We want to test the application. And we want to make sure that every error is possibly worked out at this point. Just like with systems analysis, with software development, if there are like minor, like non-show-stopping errors and you want to release the software out, that's fine. We can make those corrections later. We can patch it. We can do all that later. It's later in this cycle. But at this point, if there are very, very few errors, we're going to move on to step 5. But think about this. There are 5 different ways that you can test a program or an application. One is to actually print I know this is going to sound sick, is to physically print all the code out and put them on the desk and review it line by line. Now, I know that sounds gross. That's what we call a desk check. We can also perform a manual test, meaning I'm just going to go in and start testing the code or the statements, maybe line by line, just go through it. Now keep in mind that translators versus compilers. So there are programs out there that as you're testing it, when we're translating one line at a time. When we're compiling, we're running the entire process without going line by line through the code. So translation is one line, compile is the entire process. So just keep that in mind when you're going through this. Sample data is another one. So sample data, somebody might give us some data to test, and we as the programmers go in and just do the testing. My favorite one up here is the words beta testers. Those are my favorite words. Why? Because guess who we can go get to test our program? We can get people to do it for free. And they can report all the errors for us. That frees up our time to do other stuff. So when you see beta test up here, Yeah, I'm guilty too. I beta tested Office for like quite a while because they gave it to me for free and I could use it. That was the only reason I did it. And then if I had an error, it would prompt me to send the report. And I'm like, yeah, go ahead and send the report. Or I'd click the frowny face and it would send it. It was a frowny face or a smiley face, and I got the error. I'm like, well, which one am I going to click? I'm like, I don't want to see that error. So anyway, this is where we try to debug the application as well. So there are two different types of errors. Syntax errors are violations of the programming language's rules. As you can see here in the example in the bottom right, it is missing a semicolon at the end of the line where it says syntax error. It does give them the notification at the bottom that it's missing a semicolon. That is a syntax error. Logic errors are a lot tougher to catch than syntax errors. Is it possible for a programmer to put the wrong values in for calculations? Yeah, very much so. So maybe they missed a decimal place. Maybe they put the wrong number in. Maybe they transposed two numbers. Maybe they put a greater than symbol when it should have been less than. Or maybe they put equal to when it should have not been equal to. Aha. So those logic errors are a little bit tougher to catch than syntax errors. Now, of course, you do have programs out there like Visual Studio that's out there now from Microsoft. So they've got that out there now where you can actually run line by line and see what errors happen, and you can catch them that way. But like I said, there's all kinds of different ways to test your program. Now, I know I've said this 1,000 times before, but we need documentation. We need documentation. So the documentation is the written descriptions about the program. It's carried on throughout all of the programming steps as you've seen before. There are 3 very important sets of people that will use or support the program. The first set is you and me, the users. That's you. Then we have another set of people called the operators that work with all the error codes, and they collect all the error codes, and they end up making a database of the error codes so that, yes, the users, that's us, understand what an error actually means. And then last but not least are the programmers for updates and modifications to the program. So they need to have all of this as well. So you notice what in the upper right corner, we have review, that's reviewing everything, finalize, and the big one is distribute. So now we're ready to go. Hopefully whatever app store we've sent our application to, they've accepted it. And they said, yes, you can sell it. Unless you want to make it free, with like a nice paywall so that people, if they want the other features, they gotta, the paywall. Or you gotta hit the button and pay the money to get the rest of the features. You can always do that too. I know. Me being all sneaky with the paywall stuff. All right. Like I've had students in my class go, what is this paywall thing I hitting? And I see it there in the wrong place, and I'm like, you clicked the wrong thing. You don't have to pay for that stuff. All right, so anyhow, the final step. I told you this is going to be a short lecture today. The final step is program maintenance, which is 75% or 3/4 of the lifetime total cost of all applications is maintaining it. So like I said before, your program might not be perfect. It might still have some minor errors that need to be fixed. So we can do that through 2 things, patches and software updates. You all have phones. You all know that software updates happen. I like my software updates to occur at 3 o'clock in the morning. What am I doing at 3 o'clock in the morning? Sleeping. Thank you. When I was younger, people were like, partying? Grading our papers? Yes, I used to do that at 3 o'clock in the morning, partying and grading papers. But now, I'm slightly older, I have to tone that down. And so, yes, anyhow, software updates happen. Of course, I like the ones where it changes the look of the operating system on the phone. Like you go to bed and it's one, you wake up and it looks totally different. You're like, okay, what happened? So I changed that. I changed it to I choose when the update is going to happen. So if I'm going to bed, I go, boop, update, put the phone aside. I know it's happening, so I'm not caught off guard in the morning. But software updates have to happen to all the applications on our phones too, right? Like, yeah, it always tells you to update stuff. Think about all your food ordering apps. Why I have 15 of them on my phone, I do not know. Because everywhere I go, it's like, I better start getting the points for this stuff. So, yeah, you need an update to that app. You need to think about all your games you have to have updated. Like, those update constantly. And these software updates may be something like, it may even be a patch. So a software update could be a patch. I want you to think about patches as, normally these are to patch security problems with the application. Usually you see a lot of patches for security problems. Sometimes with patches, it's to actually update certain parts of the software. So if you see a patch and you install a patch, that's one way to update your application or your program. The other one is software updates. Usually with software updates, it's usually a bunch of updates at one time. It's not usually just like one little tiny thing. It's usually a bunch of things at one time, especially like with our operating systems. And of course, with agile development, software developers are always looking at changing needs of users. So I want you to think back to what I said earlier. There might be multiple versions of a product or of a program that's out there. There might be a light version, a pro version, a regular version, a home version, a student version, etc. So there's always changing needs. So programmers use tools like computer-aided software engineering, and they also use object-oriented programming. That is not a typo, OOP. So object-oriented programming using object-oriented software, such as the Eclipse platform, which you see here, which used to be used for our Java classes. I don't know if it's still being used for our Java classes, but you'll notice all the little boxes. So inside all of those boxes are program statements. Remember the statements I talked about before? Well, this software focuses more on the relationship between the different processes in the program rather than on procedures. So it's more visual, it's a lot more visual. So keep in mind that these objects contain both the data and the processing operations needed to perform a specific task within the program. All right. So, over the history of time, I killed the video for this. Just for the record, if anybody's seen me do this lecture before, which there's a possibility some of you have out there, I got rid of the cheesy video at the end here. I've decided to update the slides and get the cheesy video out of there. So, there are 5 different generations of programming languages, ranging from machine-like languages to human languages. And here they are. I hope you know this is binary code. Oh, that's right, it's on the slide now. I added that. So, I hope you know that zeros and ones are binary code. You all know what that says, right? Come on, shake your head with me. Shake your head with me. No, we don't know what that is. But who knows what that is? Yes. Okay, the computer knows what that is. There's no way I would ever memorize all that stuff. That's nuts. So as time went on, assembly languages came out. And yes, companies in this city still use assembly language. It's called assembly language. But you notice the difference. There's actually a word here, right? There's actually a word that we can read, like add. We're adding something. Okay, that's great. So you notice there's a big difference between first and second. Now, let's get into things that I hope you've seen before. Maybe you have, maybe you haven't. I know you've seen the 4th generation in this class. But anyway, 3rd generation. Now we got Java and C Sharp, where you're seeing more words. If the score is greater than or equal to 90, the grade is equal to A. You can read that. Query languages. This is the answer to one of your quiz questions today. I know you're all just going to yell it out when we get there. So 4th generation languages, like structured query language, you notice it's a lot of words instead of numbers. There's a lot of words here. You notice with assembly languages, there's a lot of numbers. And then there's less numbers. So what do you think the 5th one's gonna be? Think there's gonna be any numbers in the 5th one? Nope. So languages like Lisp and OPS 5 are problem and constraint languages. You notice that's all words. So we went from numbers to words. But Nick, what if I want to make calculations? I have to have numbers in there. Yes, that's correct. Yes, Yes, I understand that. Yes, I know you do. I know you do too. Sure, a lot of people here today. Did y'all get scared and show up? They all showed up. Okay. So anyhow, you're like, already? Yes, I told you this was a short one today. Oh man, we're over 50. I'm sorry. Okay, so computer programmers create, test, troubleshoot, update, and repair programs. So degree in computer science or information systems, or IT. And just think about this. You do need a lot of you gotta have logical thinking, you gotta have great attention to detail, because you saw all that code. Like you saw those, like these applications, these programs, have mounds and mounds and mounds of code. And I'm gonna tell you, the median wage has changed tremendously between 2022 and 2023. So it was like 90 grand before, now it's almost $100,000 annually. No, the 2024 stuff, if anybody's fact-checked me on BLS.gov, you know they haven't put the 24 numbers out yet because, well, 24 hasn't been completed yet, so we're still in it. But anyhow, that's the career in IT. Look to the future. We're pretty much already there as far as programming robots. We're pretty much there at this point. It's just a matter of time. We already have vacuums that we can remote control. We've got drones. We've got all kinds of robots that are floating around out there. Heck, we got cars that drive themselves. That's some scary stuff right there too. Yes, one of my coworkers actually drove to work not touching the wheel. And I'm like, that's some scary stuff right there. I have to have my hands on that. I have to have my hands like maneuvering the vehicle, otherwise I start freaking out. Oh, that's right, I'm still on camera. Sorry, honey, if you're watching this. Okay. All right, anyway, when other people drive, it freaks me out too, so, okay. So, and I just said that, darn it. Sorry. Okay, all right. Well, everybody, I want to thank you very, very much for watching. Almost 2,000 views on the YouTube channel. That's awesome. The macros video has been the most popular one thus far. It's had well over 300 views already just on its own. So everybody out there, I know you're loving this. I know you are because I see the numbers. Everybody at home, you take care and have a great, fantastic rest of your week. Wait, no, we're going to see you on Thursday. And then you'll have a fantastic rest of your week.